Hi everyone, Miss Bung here. Today we are talking about solving quadratic equations. So we're going to talk about using factoring and using the quadratic formula. So some stuff that we've sort of been incorporating here and there into geometry, but here's where we finally really focus in on it. So we'll start with factoring. When we solve quadratic equations using factoring, there's a key concept called product property that we have to use. And we use this in every factoring problem where we are solving an equation. So the zero product property, or ZPP, states that if AB equals 0, or even maybe more generally, if any product of factors, even more than just 2, is equal to 0, then A could be equal to 0, or B could be equal to 0, or they could both be equal to 0. So we're saying A and B are really the factors of our quadratic or even higher order polynomial. So let's apply that. Let's give that a shot here. Now we are given actually an equation that has already been factored. We're looking at a quadratic that is in factored form. And I know this is a quadratic because I'm looking at the two factors I have, and I know that if I were to FOIL those two back together, then I would have a 3x squared term involved in that equation. So an x squared being our highest degree term would tell us that we have, of course, a quadratic. Now solving using the zero product property means, okay, either x minus 2 is equal to 0 or 3x minus 5 is equal to 0. Again, because we know their product is equal to 0 here. Now, when we solve quadratics, we are generally saying like, well, we don't know which is really equal to 0, and we want to know all possible solutions. So we say, well, let's just make them both equal to 0. So that's what we will do. X minus 2 is equal to 0 in one case, and 3x minus 5 is equal to 0 in the other. So solving these two cases is relatively straightforward. On the one hand, I just need to add 2 to both sides, and I end up with x is equal to 2. That is one of my solutions. There is, of course, another. If we look at our second case, I need to add 5 to both sides, and I'll end up with a 3x is equal to 5. So I do still need to divide both sides by 3, and I'll find that my second solution is x is equal to 5/3. So when we write out our solutions to quadratics, we generally put them in like a list or a set. So I might say that overall my solution is x is equal to 2 and 5/3. Not like 2 and 5/3, one number, but two separate answers there. Of course, just a note, the order of these two answers is interchangeable. There's nothing in particular you have to shoot for there. Okay, let's maybe look at a more complicated example where the factoring isn't already done for us, and talk about maybe some tips or strategies involved with solving. So I'm just going to go through the tips that we have here first. The first one is probably the most important. We always, when solving any quadratic using any method, want to make sure the equation is set equal to 0. Sometimes that means manipulating the equation a little bit, moving certain terms to one side or the other, but this is super crucial. We also want to combine any like terms. So if we have multiple constants in the equation, we want to add or subtract those all together. If we have multiple x squared terms, you know what like terms are. It also helps to write our terms out in descending degree. So what that means is generally we'll have our x squared term. I'll write it with our a coefficient to be general. Next, we'll have our linear term. That's our term with no exponent on the variable. And then next, we'll have that constant term, which is just the number, no variable. So that's what we mean by descending degree. We, of course, got the degree of 2 for our first term, degree of 1 for the second, and degree of 0 for the last. It is going to be helpful to factor out any greatest common factors we can find. That'll help keep things kind of simplified for us. We also want to make sure that we do check our answers. So let's look at our example that we have here first. 6x squared minus 7x is equal to 10. Notice right now it's not equal to 0. We need to move our terms all to one side so that the other side is equal to 0. Generally, it doesn't really matter which side is equal to 0. I tend to just go for whatever is like most straightforward. So I will probably just subtract 10 from both sides of the equation so that we have 6x squared minus 7x minus 10 is equal to 0. Okay, so I don't see any like terms to combine. It's already in descending degree. I don't see any common factors that I can factor out. So now we are left to simply factor this trinomial. Now I'm going to factor using grouping, meaning I'm going to take my first coefficient, 6, my last coefficient, negative 10, and multiply those together to get negative 60. My middle coefficient, negative 7, is also important. So in grouping, we're looking for two numbers. I'm going to call those two numbers P and Q, where their product is negative 60, and the sum is negative 7. Okay, so we want to be thinking about what are the factors of negative 60, like maybe negative 30 and 2. Oh, but that doesn't add up to negative 7. So you do want to play with this a little bit. There's a little bit of, guess and check involved. But in general, we should come up with P and Q will be equal to negative 12 and 5. Okay. So of course, that tells us how we break apart our middle term. So I'm going to rewrite this trinomial now as a 4-term polynomial, 6x squared, and maybe I'll write this in red. We're going to break apart that negative 7x into negative 12x and 5x, and we're still subtracting 10, and it's still equal to 0. Okay, so let's see, we do want to go ahead and proceed with grouping, meaning we need to put the first half in parentheses and the last half in parentheses. Now we factor out the greatest common factor. So the greatest common factor of that first group, it looks like is going to be a 6x. So in parentheses will still be left an x and a minus 2. All right, let's move on to the next group. The greatest common factor I can see between 5x and negative 10 looks like it's just going to be 5. So we're going to be left with x minus 2 in parentheses again. That's good. We want the parentheses to match up. So our two factors are made up, of course, of the thing left over in parentheses and the pieces that we factored out. Those greatest common factors, those together make up our other factor. Therefore, factored form of that original quadratic is 6x plus 5 times x minus 2. And this is basically where we were in the previous example. This is like where we started in that previous example. Now we're finally ready to apply that zero product property, or ZPP, which of course means each of our factors is set equal to 0 by itself. So we'll have 6x plus 5 equal to 0, and x minus 2 is equal to 0. And now we solve both of these. So of course the one on the right is easier. All we need to do is add 2 to both sides, and we'll get x is equal to 2. That's one of our solutions. On the other side, we have perhaps just an extra step. We need to subtract 5 from both sides. Let me make sure, yeah, okay. And so we'll end up with a 6x is equal to negative 5. And now we need to divide both sides by 6. And we'll end up with our other solution of x is equal to negative 5/6. So I don't exactly have room on this slide to go back and do my last step, which is to check my solutions. Just keep in mind that in order to verify that you've done all your steps correctly, plugging your x values back into the original equation is the way to go to make sure you are all good. So I'll list my answer here as a list. Again, I would prefer to go back and check my answers, but just for time and space reasons, I'm going to skip it. All right, let's do one more example where we're using factoring. Okay, this one is perhaps a little bit more complicated, a little bit of extra step involved. And I think that is first going to be, well, there could be a couple first steps. We can see right away that this isn't set equal to 0. We can also see that there's going to be some need to use the distributive property. So I might go ahead and distribute first. I'm going to distribute 3x across the first set of parentheses and x across the second. So once we distribute, we'll end up with 3x cubed, 3x times x squared. All of a sudden we've got a cubed involved, plus 6x squared, and that's equal to x squared plus 2x. Okay, so maybe now I'll actually go ahead and set this equal to 0. So that's going to involve subtracting x squared from both sides and subtracting 2x from both sides. So I'm going to do that all at once. Our equation, it's not exactly a quadratic at this point, is 3x cubed. Let's see, how many x squareds do we have? We have 5 of them now, and we have a minus 2x, and all of that is equal to 0. Okay, so this is now a cubic equation rather than quadratic, but we're still going to be able to solve it. Notice that in each of these terms there is an x. That means that is a common factor that I can factor out of this whole side of my equation. So I'm going to write this as x times 3x squared plus 5x minus 2, and that's equal to 0. Now this x, we're going to make sure we keep that around. That isn't going anywhere because this is actually a factor. I'm going to write that here for now. That's going to be part of our solution eventually. Now we also, though, need to factor this quadratic that's now in parentheses. So I'm again going to use grouping. Grouping meaning I'm going to take my first coefficient 3, my last coefficient -2, multiply those together. So -6 is the product I'm looking for. My middle coefficient 5 is the sum I'm looking for. So between those two, it looks like a +6 and a -1 are going to be my two numbers. Maybe we'll just write that out, 6 and -1. Again, that tells us how we break apart our 5x. So let's write that out for now. We've got still on the outside of that equation our our x, and then our 3x squared plus 6x minus x. Do I want to write it in that order? I think I actually want to switch that up. I think I'm going to write minus x and then plus 6x. And let's see, then we have our minus 2, and that's all equal to 0. Okay, so grouping. Again, we want to group the first half and the second half. So I want to point out what I did here. In switching the order of my negative x and my plus 6x, notice that in each of our two groups that we now have, there's a subtraction sign. If I had not switched the order of those two terms, I would have one of these groups have a plus sign between the two terms and one have a minus sign. So there would be some extra work involved. I recommend when one of your terms that you're using to break apart the middle is negative and one is positive, try to get your groups to kind of match up in terms of these signs like we have here. And that's one way to keep things a little bit simpler. Okay, so I'm actually going to, now I'll keep working down here. So we've got our x, and then if we factor out the greatest common factor from that first group, I think we're just going to have an x. Yeah, I think there's just an x involved. Okay, so let's see, what's left over? 3x and then minus 1. Okay. Now let's see, if we factor out the greatest common factor in the next group, we're going to have a plus 2 and a 3x minus 1. Okay, good. I like that our things left in our brackets here match up. So let's maybe go up here. Our factored form, again, we've got that x hanging out on the outside. Let's take the first factor as what's in parentheses, so 3x minus 1. And then our last factor will be the two greatest common factors we pulled out, so x and then plus 2. Okay, so this is our fully factored form of the original. Notice that we actually have 3 factors. Like I said before, x represents a factor by itself. These, of course, would be our other 2. So when we now go to apply our zero product property, we also set x equal to 0. So we'll say x is equal to 0, 3x minus 1 is equal to 0, x plus 2 is equal to 0. What that means is that we already have one of our solutions. One of the solutions is literally x equals 0. We have to do maybe a little bit more work to figure out the other 2. So let's see, I will perhaps add 1 to both sides first for this middle one, and then we will need to divide both sides by 3. Okay, so we'll end up with another solution of x is equal to 1/3. And then in the last case, we'll just want to subtract 2 from both sides to end up with x is equal to -2. So all together, we have 3 solutions, 0, 1/3, and -2. Again, I'm sort of skipping over the step where we would go back and check our work, but I think we get the idea there. All right, let's talk about that quadratic formula. So first of all, what even is the quadratic formula? Some of you may have this memorized, some of you may not. Some of you may have heard the song that you can use to help yourself memorize this or come up with it. I will link that in the calendar for today. I don't really feel like singing it, but here is what the quadratic formula is. So if we have a quadratic equation that is in this form, again, we're going to call this standard form. Standard form, where we have our coefficients a attached to the x squared term, b attached to the x term, and c is just our constant. And again, notice it's set equal to 0, super important still. Then we can say that our solution, or really our solutions to the equation, are given by this formula. X, being our solution, is equal to the opposite of b, or negative b, plus or minus. So this is how we end up with multiple solutions, because we've got a plus or minus here. The square root of b squared minus 4 times a times c, all over 2a. So that is our quadratic formula. it is going to be helpful to have this memorized. And again, the song that you can find the link to in the calendar can be really helpful. So why don't we look at a couple of examples where we can apply the quadratic formula. So in our first one, example 1, 3x squared plus 5x is equal to 1. All right, so the first step is not to just plug stuff into the quadratic formula. The first step is actually to set this equal to 0. Again, that's really important. So that means subtracting 1 from both sides of the equation. So we'll end up with a 3x squared plus 5x minus 1 is equal to 0. So from here, it's really easy to identify our A, B, and C that we end up having to plug into the quadratic formula. A is going to be equal to 3, B is going to be equal to 5, and C will be negative 1. Okay, let's take that formula. So x is equal to, okay, the opposite of b, negative 5, plus or minus the square root of, okay, b squared, 5 squared, minus 4 times a times c. Let me finish my square root there. All divided by 2 times a. Okay, now our task is simplifying. So let's do that. We're going to have negative 5 plus or minus 25 plus 12. So notice 4 times 3 times negative 1, that would get us negative 12, but we're subtracting that product, so we'll end up adding 12, and that's all divided by 6. Okay. So let's keep going. Under that square root, I think, is the only work we've got to do, and we get, what, a total of 37. Not a square root, not a radical that I can simplify. If this turns out to be something that I can keep simplifying, then we can have a list of values again. But in this case, this is how I would represent my answer. X is simply equal to negative 5 plus or minus the square root of 37 divided by 6. You can write this another way. You can write this as x is equal to negative 5 plus square root of 37 over 6 and negative 5 minus the square root of 37 all over 6. Unnecessary though, really. It's just easier to use our plus or minus when we can't simplify. So let's look at the next example. This time we have, oh, it's very similar. 3x squared plus 5x is equal to 12. So almost identical first step. I'm going to subtract 12 from both sides. So we'll have 3x squared plus 5x minus 12 is equal to 0. So we're going to have the same a, 3, same b, but now our c is negative 12. Okay, so that means when we plug into our formula, we'll see a lot of the same stuff. Let's see, opposite of b, negative 5, plus or minus 5 squared, I'm just going to write that as 25, minus 4 times 3 times negative 12, all over 2 times 3. Okay, so let's simplify. Okay, so x is equal to negative 5 plus or minus 25 minus 4 times 3 times negative 12. Let's simplify that. That's going to be 12 times 12. Okay, so 144 there, all over 6. Okay, now 25 plus 144, that's 169, which is a square number. So we are going to be able to simplify this down to 2 numbers. Let's see, I wanted to write 169 there. Okay, so the square root of 169 is 13. So we don't want to leave our answer here because we can actually add 13 and subtract 13 to get our two different numbers or two different answers. So maybe up here, we won't go that far. I'll write the first case, which is, let's just do -5 minus 13 over 6. So -5 minus 13 over 6, that's going to be -18 over 6, which actually simplifies all the way down to -3. Okay, that's one of our answers. Now the other answer, let's do that over here, is when we say it's -5 plus 13 divided by 6. So -5 plus 13, that's going to be 8. So 8 divided by 6. Again, that still simplifies. That's going to be 4/3. So overall, maybe I'll write my answer at the top here, our solutions to this problem can be written as -3 and 4/3. Okay, so again, just a couple of examples using that quadratic formula, and as we did before, using factoring to solve. Have fun practicing this, everyone.